So the quadratic formula helps a lot when solving those quadratics that don't factor very well. And now you won't have to factor. All you have to do is get the equation into this form. Ax squared plus bx plus c equals 0. So you always have to set it equal to 0. So in example 1, I have to subtract 14 from both sides. And then I have x squared minus 5x minus 14 equals 0. Before, I would have had you factor this. Look for the factors of 14 to add to 5. In this case, we know the answer is going to be 7 and 2. This time, I'm going to use the quadratic formula, which is listed right up here. Okay? You can always remember the quadratic formula by singing the Pop Goes the Weasel song. I know it sounds stupid, but x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's how I remember it all the time. I'm sorry for that. Anyway, so the next step, I have to identify a, b, and c. A is always in front of the x squared term. So a is 1. B is negative 5. C is negative 14. So now I plug it into the formula. So opposite of b plus or minus, remember the plus or minus with the square root of negative 5 squared minus 4 times a times c, which is negative 14. All over 2 times a, which was 1. Now I just reduce. Negative 5 times a negative 1 is 5 plus or minus the square root of 25 plus 56, because there's a minus and a negative, that becomes a plus, all over 2. So then I add those together, 5 plus or minus the square root of 81 over 2, which the square root of 81 is 9. So that's 9 over 2, and then I split it. 5 plus 9 over 2, and 5 minus 9 over 2. 5 plus 9, 14 over 2, which is 7. 5 minus 9, negative 4 over 2, which is negative 2. Those are my answers. I didn't have to factor. This is example 2. It's a little bit more complicated, but it's the same principle. First up, always get it equal to 0. Then identify A, B, and C. A is 6, B is negative 2, C is negative 1. Remember, signs matter. So, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Plug those in. Simplify. This becomes a 2 plus or minus the square root of 4 plus 24 all over 12. Now I do the 4 plus 24. 2 plus or minus the square root of 28 over 12. In the previous examples, we broke down the square root of 28. We're going to do that again. Square root of 28, because it's not a perfect square, I look for some. So that's going to be the square root of 4 times 7. I then can take the square root of 4 and get 2 square roots of 7. So I'm going to replace that back in. 2 plus or minus 2 square roots of 7 over 12. Do you notice that the 2 and the 12, 2 and the 12, I can reduce them just like I'm reducing a fraction. So my final answer is actually 1 plus or minus the square root of 7 over 6, All I did was I divided 2 by 2, 2 by 2, and 12 by 2, and got 1, 1, and 6, just like I reduced down a fraction. And I'm done. I leave it like this because then I avoid all nasty decimals. The next example is again something like that. Again, start off equals 0. A is 5. B is -2. C is 4. Now I put it into the formula. Opposite of B plus or minus the square root of B squared minus 4AC all over 2A. I'm then going to reduce 2 plus or minus the square root of 4 minus 80 over 10. I am then going to simplify the square root into 2 plus or minus the square root of 76 over 10. That's a -76. Every time I have a negative square root, remember there's an I. Okay? So then I'm going to break down that 76 just like it did before. -76. That's going to break down, and I need some perfect squares out there. So those perfect squares are going to be 4 and 19. You wouldn't come up with it unless you started doing the 2 times 38, 3 times, oh, that doesn't work, 4 times whatever. You're plugging it into your calculator. Remember, there's a -1 there. So really, the square root of -76 comes out to be 2i square roots of 19. Because again, square root of -1 is I. So I'm going to replace that in. 2 plus or minus 2i square roots of 19 over 10. And just like I did in the previous example, 2 and 10, 2 and 10, I can reduce that just like I did a fraction. 1 plus or minus, now that 2 goes away, but I is still there, I square roots of 19 over 5, and I'm done. I leave my answer as that.